Hey everybody. Alright, so we're going to do a quick video here to show some of the basic features of our WINDLDR ladder logic programming software for IDEC. First thing I have to do is open the program, so I find my WINDLDR shortcut, which is up here in the corner. I'll double click this guy and it should open up. It opens up on the wrong monitor, so now I gotta move it over. Okay, cool. So this is all assuming that we've installed it already, right? We've entered in the serial number and pass key for the software, right? So we've already done all that. We've got working software now. So first thing we always want to do whenever we open up the software is make sure that we have the correct device type selected. So there's some tabs up here we can go to from the Home tab, navigate to the Configuration tab, select our PLC type, and just make sure that this matches whatever model PLC that we're working with, right? For us in the lab, we'll use, I believe, this model are the two that we have. I'll go ahead and leave this one. I have this set as the default. If I want to change the default type, I just select whichever one I want and then say use as default, and you'll see that populate down here as the default device. But I'm going to leave that as my default and say OK, but that will be specific to whatever device you are using. You can also come down here in the bottom left corner, you can click on that and you can select from a list here kind of quickly too, right? So there's like two places you can get there. So let's go back to our Home tab. In this Home tab, we've got this toolbar up here. You can kind of customize the view of these toolbars. We'll go through that a little later. But you've got your, copy paste tools. You can cut, copy, paste, right? All good. We can make new programs. We can import programs. This select just gets me back to a selection tool. So like anytime I have just a regular old mouse cursor, right? I'm in the selection tool. You can select rungs or select all. We don't have anything in our program yet, so there's nothing to select. We just have rung 1 here and there's nothing in it, so not a lot to see. Basic commands here is next. And these are all of our basic commands. Now, we're not going to go through all of the functionality of every single thing in this video, just showing you kind of where it all lives. But our make and break instructions, right? So in IDEC, we call these normally open is our make, or examine if open, and XIO. And the normally closed is a break instruction, or examine if closed, XIC. Right, so that's kind of those are all similar terms, right? Equivalent terms, they mean the same thing. In IDEC, they like to use the normally open, normally closed. I think that gets a little confusing because they don't behave exactly the same way that normally open and closed contacts on a relay behave, right? So it's a little different in the PLC world. So thinking about these as a make and a break, normally open would be a make, normally closed would be a break, is a little more helpful in my opinion. We'll discuss this concept at great length. Just know for now that's where those are. Then we have outputs. Output not does the opposite of what a normal output would do. We have a set and a reset. These are great for latches, right? So this lets me do latching functions for outputs without creating a standard relay-based latching circuit, right? Our holding circuit or latching circuit. We can skip some of that logic by simply using a set and a reset. We have one-shots, or a single output up or a single output down. We'll go through those in detail. Timers, counters, shift registers, counter comparisons, data register comparisons, and some program flow management, right, for like ending a program, that sort of stuff. So that's all in our basic commands. Our advanced commands, there's a whole bunch of other stuff in here. We will not use everything in here through the course of this course, but we'll use some of the things in here, and we'll explain those, the functionality of those as we go, right? But for now, let's just keep this simple and quick. That's where all of these, like, things we will use, moves, data comparisons, all very good. You know, we'll go through some of these other tools in here. And if you ever find yourself, here's another little tip, wanting to use an instruction and you're not sure what it does, you can select it, and I've just inserted this PID. This is for a PID controller, and if I hit F1, it brings up a help menu, and I can search for that thing that I'm looking at. Now, if you actually go into a window, so all I did here was just double click on this guy, and it brings up this dialog box, which lets me set some specific parameters for this object, right? This is a function block. If I hit F1 at this point, it should, and it actually didn't do that, and I don't know why. Let me bring this back over. It keeps opening this on my other screen. Typically, it'll actually bring you to the page that is associated with the thing that you're looking at. So it would actually, normally would just jump me to this PID control instruction. And so if you find something and you're like, how does this work? I'm not sure. You can always find it in here and kind of read through the basics of what does this thing do? How do you set it up? And we'll use that periodically to look at some of the different commands and instructions that we're going to use through this course. But just a little tip. I'm going to get rid of this. I don't want this in here right now. I'm just going to select it. I think I could just select one part of it. And if I hit the delete key on my keyboard, it'll go away. I could also hit the delete right here, and it will delete whatever, if I have a selection, delete a ladder line, like it'll, do whatever I want it to do here. I can delete the whole rung, a column. So remember, rungs go this way, right? Columns are vertical. Just so we can make that distinction. Okay, so that's our basic commands, our advanced commands, right? So these are instructions that we're putting into our program. And we're not going to get into macros in this class, so I'm going to leave that alone for now. But there are some things we can do with that. The other thing we have up here is a draw tool. So when I click on that, you see my cursor turns into a little pencil. That means I'm currently in this drawing tool mode. So now I can draw ladder lines. Okay, that's kind of useful. I have an eraser. Now you see my cursor is now like a little eraser. That lets me highlight things. You see how it kind of turns red, and I can delete it. It's a little finicky to make this thing work, but it is useful, and there are times when you're going to need to use it. And then we have just making horizontal. If I just click this horizontal, it just adds a horizontal line. Wherever this blue box is, it's going to populate a line in that column, right? So this like blue square represents one column on my overall rung. Then I can do the vertical, same thing. Now it's gone down one column vertically, right? Boom, boom, boom. Control Z, undo. That's your best friend in any software. Control Z, undo. That's the shortcut. That's what I'm doing right now. Control Z, Control Z, Control Z. Okay, cool. I never use these tools, increment, decrement, invert, but you can kind of get an idea. If you just hover over it, it'll kind of tell you what it does. It increments the addresses of all devices used in the selected instruction by one. So if you need to change the address of something and you just want to increase it by 1, you can click that and it'll do it. We'll get into addressing here in our next video, so don't worry about that if it doesn't make sense to you yet. Rung comments are very good. We like rung comments. When I click on that, it pops up this dialog box. It popped up on my other monitor, so I had to drag it over here. I can add in testing the comments. So we'll add that in. Hey, look at that. It popped in my comment. This is useful for naming what a rung does. So if I was going to make an instruction to control a pump motor, and it's my, fill in the blank pump motor, whatever descriptor you want to apply to that, I would put that comment in for this just so that I know when I go back, oh, this is where the start and stop function for my pump control is, right? And I'd put that in my comment, start function for pump number 1, or whatever it is. So very, very good, very useful. We can insert ladder lines, columns, rungs. You'll kind of get a feel for how these work as we go. Same with the append here. They do behave a little differently, and we'll play around with those, and you'll get to see how they work. Jump to the bookmark position, and you can set your bookmark, right? So where you want to jump to. We can find, replace things, right? Search through your programs. As they get more complicated, that can be useful. And I never really use the check for errors in here because generally we'll just set things up and not have too many errors. But if you do have an error, it should actually pop up down here in the bottom, and we'll see if there's a problem, and it'll actually tell me what rung and what line it is, where the issue is, and then we can go back to it and find it. Okay, so moving on to the configuration tab, we will use a few things in here. Obviously, the PLC type we'll absolutely use. If we have modules that we're expanding, we can click on that, and it'll bring me to this screen. I can also get there right from here. So this is my main program. And then this is that module configuration. Boom, that's when I click this expansion modules, it actually just takes you to this tab. Here's my PLC. This is the type we've selected. This is one that we have in the lab. We do use some digital expansion modules. So I have digital I/O modules in the lab. I can't remember which model we have, but when I click on one, you get to see kind of a preview of it. It tells me that it's for 1224 volt DC, gives me some of those specs. So if I don't remember which one I have, I can go, okay, yeah, that's probably that one. But always I just want to look at the device and find that model number. I mean, that's what you want to do. Yeah, we've got one of these. These are the same model, I believe. The only difference being this one has screw terminals. This one has push-in terminals. So they just update the little picture that you get based on the one you have. And I can just drag this over. So all I did, I'll go back. I clicked, held it, clicking and holding, dragging it over here, and I'm dropping it in. Bam. I just added a module. So whatever modules you have, you find them over here, and you can drag and drop them over. We've also got some of these analog cartridges, and we've got, I believe it's this guy. And that one actually does not fit on this PLC. Haha, it's for a different model that we also use in the lab. That is actually attached on the front face of the PLC. So if you're in that PLC1 class, you're going to see these analog cartridges on our PLCs, and we'll go through this process in class. Okay, so once I've got my PLC set up the way I want it, we're good. We don't have to go any further here. We can run and stop our programs. We're not going to go through all of these. The kind of big ones that we're going to look at, we will eventually look at input configurations, because we will have to configure some inputs. And we will look at our COM ports, and we will look at our Ethernet ports. So eventually we'll set up our IP addresses for this device, and that will allow us to communicate with other devices that we're connected to on our test panels, right? So we'll have an HMI that will have its own IP address, and basically we just have to set the first 3 digits of this IP address is identical to the address on our HMI, right, and vice versa. And then we'll change this 4th set of digits for each device. So each device will get its own unique digit here, up to 3 digits. And as long as we've set this 3 sets of digits identically on each of our devices, and our subnet mask matches on each of our devices, then we'll be good to go, and we should be able to make all these things talk to each other. And we'll use one of these Ethernet ports as a means of programming as well. So we'll have to set the IP address of our computer that we're programming with to allow us to communicate with our PLC. Okay, so that's where that stuff lives. In this online tab, we can download programs to the PLC. We can upload programs from the PLC, and we can start and stop here. We can clear errors in that maintenance tab, which we really shouldn't have to mess with. And then this monitor button here, we can start and stop monitoring mode. I am not connected to a PLC currently, so this is not going to work. We have to be connected to a device and have that device powered on in order to go into this monitor mode. The monitor mode allows me to see in real time the status of inputs and outputs, and what that means for our PLC instructions that we have programmed. So super useful for troubleshooting, like our initial setup. When we power things on and something's not working right, we can do a lot of debugging and troubleshooting with this monitor mode, without even having to get out our digital multimeter or anything like that. We can kind of see what's going on in our program, and it's very helpful. Simulation mode here is also very helpful, but you really have to understand how the real world devices, your field devices, are going to interact with your PLC system in order to properly simulate your program. Because you can simulate it in a way where everything will work perfectly, and you'll say, this is going to work great, but your simulation may actually not be set up correctly to match what's really going to happen in the real world. So this is a great tool, but it can be misleading if you don't have things set up correctly. All right, so we'll go through all that as we go. And then there's a communication setup, and this is for if we're going to program via Ethernet or USB. We'll set these up as well because we'll use both USB communication and our Ethernet for programming our PLC. So, okay. View is the last one we'll talk about, and this is pretty basic stuff. It lets me control what toolbars I see down here in the bottom left. So do I want a project tab? Do I want the toolbar or toolbox, I'm sorry they call it. There's a tag editor. We'll go through all of these. You know, there's some things you're maybe not going to use as much. Some things you're maybe going to use a lot more. Tag editor is definitely one that we want to use. So if we do find something that we don't want, like I don't need this user defined macros right yet, so I could just turn it off. And if it's not highlighted yellow up there, it disappears from that toolbox down here. So I could say like, I don't need that. I don't need that. I just want these three guys to hang out here. So I just leave those selected. They're yellow. They're on. I can see them down here. That's all that does. So if I need them at one point, I can come back into the view and just turn them on, right? And I can say, okay, I want the info window. There we go. And I actually do like having the info window turned on. This is where those error messages can come up. So I like having that on because if I build a program and try to upload it and I have an issue, it'll show me an error down here, which is very useful. You know, what do you want to see in your program as far as tag names, device addresses? We'll show that when we start going through our programs. If I go back to the main program tab here, so this just shows me where my instructions would be if I had any, I can choose the number of columns. Right now I have it set to 9. So I have 1, 2, so let me just go 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I have 9 columns. Okay, so I can just change the width of this. I'll leave it at 9 so that the instructions are kind of larger and show up more clearly in the video. But I might need to add more columns as my instructions gain complexity, right? If I have the more things I have in a rung, the longer I need the rung to be, if that makes sense. And then line width just makes the lines like bolder. How many comment lines do you have? When we go back to comments, it'll only show one line. So if I have enough text that it needs a second line, that second line actually wouldn't show if I don't have 2 comment lines in here. What font do you want to use? Yeah, all that stuff. Pretty basic stuff. So let's go back to home. And let's just make a very simple latching circuit. Right, so let's say we have at input number 1, we've wired a green push button, a normally open momentary push button, right? So if I find my inputs on this list, and this is that tag editor, right? Boom, boom, boom. So I have my tag editor here. Find my inputs, and this is input number 0. And I can put in my device. I can say, well, this is going to be a normally open push button. Okay, cool. And then input number 1, I could do an N. Let's do another normally open. N.O push button, but this one's going to be red, and this one's going to be green. Okay, cool. So a red one, a green one, a red one. All right. So in here, let's go. Oh, See how it's not letting me do anything? I'm trying to click and it's not happy with me. See my cursor? It's still that eraser. So I had selected this eraser tool and it stayed as an eraser. There's two ways I can get back to my selection tool. Just click on that guy. Or if I'm still the eraser, if I hit the escape key on my keyboard, hey, it goes back to my selection tool. Now I can like select where my blue box is, right? What's selected in here. So I'm going to grab a basic instruction, a normally open. Bing, there it is. We've got a normally open, what looks like the same symbol we use for normally open pair of contacts on a relay. Okay. So, looks familiar. This is actually a make instruction in our PLC, or examine if open. Basically what happens is, because we're going to address this, so I just double clicked on it. Sometimes I move too quickly, so I'm going to backtrack. Double click on it. This brings up this dialog box. And inside this dialog box, we can define some things for this instruction. We can change it from a make normally open to a break normally closed. Okay, cool. I'm going to leave it as normally open. And I can change this tag name, which is our device address, right? So the address is, for my green button, I0. So I'm going to select that, just hit close. And now I see I0 here. And I see my comment of normally open push button and it's green. Okay. We can write in here whatever makes sense to us. Whatever is going to differentiate this device to you, that's what you want to put in there. So, okay. So here's my normally open push button. It's green. Cool. Now I'm going to add another normally open. But instead of just clicking here and then bringing it over, and you see my cursor has that little normally open symbol next to it. That's telling me that I'm like, hey, if you click, you're going to drop that in. So I'm going to go back to my selection tool and just get rid of it. I'm going to go just back to a normal cursor. If I go to the toolbox over here, I've also got all of my tools, and this is everything from these two buttons. And I have that normally open here, and I can click on that, and I just click it once, and then I come over here and now see that little normally open symbol is back on my cursor, and I can drop it in like that. Okay, I'm gonna delete this because I don't want to do it that way. There's another way I can do it. If you look in here, it shows us the symbol and it says A, and then in parentheses it says normally open. Well, the A key is the shortcut for this instruction. So if I just have this selected and I type in A on my keyboard, this little coil selection dialog box pops up, and I can say OK, and it goes right into the properties for a normally open instruction. And I click on that little three dot button, and I go to my inputs. If I was working with if I wanted an output or something else, I can just drop that down and find it in here. And now I can select my red button. It's also normally open. Here it is, normally open, push button. It's red. Okay, cool. I've got a green push button. I've got a red push button. And now I need a coil for my output. So what are we going to drive with this? If this is like I said before, this is a pump. Just say it's a pump. In fact, I'm going to put a run comment in. Pump 1 controls. There it is. Hit OK. All right, so this is pump 1 controls. So now I need an output. And this is going to switch my contactor. So this could be where I wire the coil of my contactor, right? So we've got our coil of a contactor, X1, X2, right? So we're gonna hook up that coil to the output of our PLC. So I say output, and now I want to drop that in. And if you remember some of the basic rules of relay-based ladder logic, we always have inputs, push buttons, right, count as inputs, to the left, and outputs, coil of contactors and output, those are always to the far right, right? So those are always going to generally be the rightmost thing in our relay-based ladder logic. It's the same thing in PLC-based ladder logic. Cool. So we learned all these rules and they all apply. So that's nice. So same thing here. I have to double click on this just like I did over here to get into this properties dialog box, and I can set it as an output, a normal output, and I'm going to click on this little button. Brings me to this editor. I'm going to find an output. And we'll just use Q0. That's where I've wired my contactor up to. Q0. And now in here, because I didn't set this up before we started in the tag editor, there's nothing in here. This comment section is blank. So I'm just going to add it in. And this is like our pump 1 contactor. Cool. Pump 1 contactor, it's Q0. Awesome. So we've got some instructions. Let's go to our online tab. Here is that simulation button. This is what I want to go to. I'm just going to simulate this. So right now, there is no logical continuity, right? This instruction is a 0, it's false, it's low. This one's 0, false, low, 0, false, low. That means there's no logical continuity here. And if I were to measure our voltage at input number 0, I should see 0 volts. If I measure voltage at input number 1, I should see 0 volts, because these are normally open buttons, right? I'm not pressing the button right now, so nothing's happening. If I were to measure voltage from Q0, that's our output, I should see 0 volts. Nothing's happening. So these two are in series, so what do I have to do? Well, this has to be pressed. Now I'm pressing this button and I'm holding it. And this is turned green. That means this has logical continuity. It's a 1, it's true, it's high. If I were to measure voltage at input 0, I should see 24 volts DC, because that's our pilot voltage, right? We're using a 24 volt DC system. This one's still low, false, 0. So no logical continuity. My output is still off. It is not asserted. If I were to double click on this or right click and hit set, that sets that bit. This is now true. It's high. It's a 1. This establishes logical continuity. Now my output is true. It's high. It's a 1. Sweet. I should be able to measure 24 volts DC from my output. Now my contactor is asserted. Contacts change states. Pump is running, right? Okay. So these are normally open, momentary push buttons. So this is where I say the simulation mode can trick you. Because what do I have to do in the real world to maintain that 24 volts that we're sending to this input and this input? Well, I would have to physically hold down those buttons this whole time. As soon as my finger lets go of one of these buttons, this resets back to low, false, or 0. I lose 24 volts to input number 1 if I let go of the red push button. Why do I lose it? Because it's a normally open button. So as soon as I stop pressing it, it reverts back to its normal state and no more voltage, which means subsequently my pump has stopped running. We have stopped sending 24 volts to the coil of the contactor. All of those associated contacts change states. The contactor opens and the pump turns off. Okay, so this is not a good way to set up a latch, right? This is not going to work very well. I set these up. I'm going to reset this as well. So we'll just go back to basics where we've let go of all the buttons. Okay, cool. We've set these up as normally open contacts, or what I will say is a make instruction. So a make instruction, when we see 24 volts at an input, a make instruction will then make logical continuity. That's why we call it a make instruction. So if the input is true, it's high, there's voltage, right? It's a 1. This normally open or make instruction will make logical continuity. That is the key distinction between a break instruction. Let's put in this normally closed, or what I will call a break instruction. So for a break instruction, if it is low or false or a 0, a break instruction will do nothing. If it's high or true or a 1, meaning we have voltage at this input, then a break instruction will break. It will do what its name says. It will break logical continuity. So let's go back to our simulation. This is not highlighted green, so this is low, it's false, it's a 0. If I measure voltage at input number 0, there should be 0 volts DC. This guy is green though, our break instruction, which means if I measure voltage at input number 1, it should be low, a 0, false. I should have no voltage. But I have logical continuity. This is allowing logical continuity even though the input state is low, it's false, it's a 0. So if I press my button and I just set this, now my pump has turned on. I have logical continuity, and then the output is high. It's a 1. It's true. If I measure voltage, I see 24 volts. Great. But I still have to hold this button down the whole time, which is less than great. So I'm going to reset this. I let go of the green button. The input's low. It's false. It's a 0. This is now low, false, 0. Okay. We can build a standard latch. We can do a standard latching circuit. So I can do it a few different ways. I can go home, I can draw a line, and I can do the old line just like I would on a paper schematic. Let me escape. And now I've put this like parallel path around that start button. Normally we would use auxiliary contacts on a contactor with relay-based ladder logic to make this latch work. But we can actually use a virtual sort of relay to establish a latching circuit just like we would with relay-based ladder logic. So I'm going to grab that normally open instruction again, and now I'm going to double click it to open up this property box, and I'm actually going to associate this instruction with our output just like we would in relay-based ladder logic. So I've got my contactor, pump 1 contactor, okay. This would normally be our auxiliary contacts, right? So it'd be like a 13, 14 would be the contact terminal numbers, and that's our first pair of normally open contacts on a contactor, right? But because it's associated with this device, this address, it's going to be Q0 over here. So anytime this changes states, this is also going to change states simultaneously, just like auxiliary contacts would on a field device, physical contactor. But this isn't a physical device. This is all virtual. This only exists as ones and zeros inside the computer. So it's actually pretty cool. Let's go back to online up here and our simulation. So let's see what this has done to our system. So if I select that normally open push button, a green push button, it is now, it's low, it's false, it's a 0. If we measure voltage at input 0, we should see nothing, no volts. If I press the button, so I set this, but now think about how a momentary button works. I want to let go of that momentary button, right? I don't want to stand there and hold it down all day to make this pump run, because that's what's happened. We've established logical continuity. Pump is on. Output is high. We should see 24 volts here now if we measure it. I'm going to let go of this button, and I'm just going to reset it. And lo and behold, because this changed states, it also made this change states. So that make instruction, when this bit became a 1 or true, the make instruction made logical continuity, right? So it followed what its name suggests. So make instruction makes continuity when it is true or a 1 or high. A break instruction subsequently breaks logical continuity when it is high or 1 or true. And I can prove that to you by setting this. So now I press the red button, because this whole time we have not touched the red button. This input, if I were to measure voltage right now, should be at 0 volts, because no one's touched the red push button. But I'm going to set it, and I'm going to touch the red push button. Now, this input number 1, should see 24 volts, because I am pressing the red button. So this is now high, it's true, and because it's a break instruction, it has broken logical continuity. So it breaks. When it is true, it breaks. That has reset my latch. This is now no longer asserted. This is now no longer asserted. And I can let go of my red push button. Now it's back to false, low, 0. There's no voltage at input number 1, and my pump is off because we reset this latch. Okay, so that's a very basic latching circuit using a virtual contacts. So this Q0, we've basically created a set of auxiliary contacts that work very much like a auxiliary contacts on a field device, physical contactor, but we've done it virtually. So just one way to do it. There are many, many more ways to do it, and we can set up other like virtual relays. There's all kinds of things we can do, but this is one way. So there's the basics. Hopefully you got something good out of this video. I'm going to wrap it up here so it's not too long, but we'll come back and talk about other types of latches as we go. I'm going to turn off the simulation mode, go back to home. If I want to save this, I can save it. Remember, when you're saving your work, and you should save early and save often when you're making programs, get into the habit of using your OneDrive account to save things on the cloud. It makes it much easier whether you're working at home or in the classroom to have all your files accessible, right? So don't rely on that thumb drive. That's like caveman technology, okay? Use the cloud. All right. Hopefully you got something out of it. Until next time, we'll see ya.